Now talking about the formation of the carbonyl compounds. So I want you always to remember that there is a relation between alcohols, carbonyl compounds, which have or whether it's a hydrogen or an alkyl group, and carboxylic acids. So what is the relation between these three? All these three, each one would represent a different oxidation state of the other one. So the aldehydes are or ketones are the second oxidation state of the alcohol. So alcohol by oxidation can change to give you aldehydes or ketones, and then you have the oxidation of the aldehydes will give you carboxylic acids. So for the aldehydes, how do we form aldehydes? If we start off with primary alcohol and then oxidize primary alcohol, then we will end up with the aldehydes. And as we said that further oxidation can oxidize the aldehydes to give you carboxylic acid. So if you want just to stop at the stage of formation of aldehydes, you have to use a specific oxidizing agent, not very strong oxidizing agent that will stop the oxidation at the stage of formation of aldehydes. Because if you use a strong oxidizing agent, then this will continue, the reaction will continue to oxidize the aldehydes and give you the carboxylic acid, which is the following oxidation state of the aldehydes. We can also, if we can oxidize aldehydes to give carboxylic acid, we can do the opposite. So we can reduce carboxylic acid to give aldehydes. So reduction of carboxylic acid with reducing different reducing agents can give us the aldehydes. And also you have to be careful because further reduction here can give you the primary alcohol. So in order to stop at the stage of the formation of the aldehydes, we have to use a specific reducing agent. For ketones, in order to form ketones, we need to do oxidation of secondary alcohol. So if we start off with a secondary alcohol when the carbon that has the OH has two R groups. So these are called secondary alcohols. So if you start off with secondary alcohol and you oxidize it, then you're gonna end up with ketone. Again, the ketone can be reduced to give you the secondary alcohol, but these ketones cannot be further oxidized to give you carboxylic acid because this is the end stage here. So only aldehydes will go further to be oxidized into carboxylic acid, but with ketone it's easier to prepare ketones because they will not be further oxidized. So if you are preparing carbonyl compounds and you want to identify the presence of the carbonyl compound, especially when we are talking about aldehydes and ketones, how can we identify the presence of these carbonyl compounds? There are two tests that we can do. The first one is using the IR, the infrared method. So in IR, we can see a strong peak around 1500 or 1600 centimeter minus 1 in the infrared spectrum. So it's going to be a strong and long peak like this one. It's very sharp and very strong, around 1500 and 1600. This is very specific to carbonyl group. You can also see that with carboxylic acid and carboxylic acid derivatives. So any compound that has a carbonyl group will show you this peak. The second method that can distinguish between aldehydes, ketone on one side and the carboxylic acids or carboxylic acid derivatives on the other sides is the formation of an orange precipitate with 2,4-dinitrophenylhydrazine. So 2,4-dinitrophenylhydrazine will react with aldehydes and ketones only, and it will form the compound that will be formed has a color, an orange precipitate. So the formation of this orange precipitate will indicate the presence of a carbonyl compound. And by carbonyl compounds, I mean here aldehydes and ketone, but not an acid or an acid, a carboxylic acid derivative. Although these two will not distinguish between aldehydes and ketones, but it can distinguish between the aldehyde and ketones and the different compounds that had a carbonyl